Good morning, good afternoon. I'm Miranda Bogen and I work on responsible AI at Facebook. Today we've been talking about responsible computer vision from a variety of different perspectives. It's obviously an enormous topic, and so I'm glad we have this dedicated space to discuss it together. On one hand, responsible computer vision may be a discrete topic within the broader computer science and computer vision research community, but on the other hand, it's a topic that's enormous unto itself. And what I'd like to do today is talk about a holistic approach to thinking through social and societal implications of different applications of computer vision. Concerns about computer vision systems often reference issues both in the implementation of systems, or, for example, whether and how well a system works across various populations or contexts, and issues of the system's goals overall, such as whether it's appropriate to use visual signals to predict someone's emotional state. Sometimes concerns span multiple levels of abstraction, such as questions about whether it's appropriate to deploy a particular CV system in a particular sensitive context, such as, say, an immigration system, given that it performs unequally well across different groups, and that could have negative impacts on those groups it doesn't work well for. The proposition that I want to present today is that by breaking down this abstract, large topic of responsibility, specifically I'll be focusing on fairness, into several distinct dimensions, that can help make this very broad topic both more tractable and more actionable. When teams that I work with are thinking about fairness in AI systems, we try to think about it at three core levels: the high-level product goal, or what the product is doing, and intended to do, the policy behind that product goal, or how that goal is being translated into the product or tool at hand, and then the implementation of that tool. We've found that by using these three dimensions as lenses to think about levels of responsibility, issues of responsibility, it's easier to disentangle some of the complex and sometimes gnarly issues that can come up when building AI-powered tools. So first, the product goal. What's a given system designed to do? What is its objective function? What are the assumptions that that's relying on? One of the most interesting things I find about computer vision specifically is that many CV tasks rely on lists of predefined concepts that someone somewhere determined are important enough, discrete enough, or observable enough to specify in a given system. But this work relies on a critical assumption that our shared reality is static, that these concepts are firm and universal. What can we learn from what we can learn from history, from policy, and from social dynamics, at least, but not limited to, in democratic societies, is that people can observe the same thing and walk away with a completely different understanding of what they saw and want to debate that. Is a group of people who are gathered in a public square with their arms in the air a rally? Is it a protest? Is it a riot? The answer depends on a whole array of different factors, including who you ask and where you are and what time it is, potentially. A computer might be able to recognize that an image could be any one of those things or potentially all of those things, but what it actually is to any given beholder depends on that variety of context, including who has power in a given situation. When building a new computer vision application, consider what its intended use is going to be, what the creators imagine it will accomplish. That can help reveal some of the assumptions underlying that system and can help illuminate the fact that careful consideration of those concepts that are being taught to computer vision systems, for instance, are particularly important, and create the opportunity to question whether embedding those concepts, those categories, into a particular application is appropriate. Take, for example, a hypothetical system that would use computer vision to grant access to a particular area of an office, maybe, let's say, to anyone wearing a lab coat. At the product goal level, one question to ask would be whether such a system would be fair and reasonable to deploy. And perhaps if a lab coat is a safety requirement in that area, that particular application might seem reasonable. Whereas using a similar system to classify people into different job functions based on what they wear in order to grant access to different parts of the work environment would be more troubling. Now let's think about it at the policy level, that second level I mentioned. Let's say that hypothetical system is instructed to classify people into different job functions based on what they wear, and instructed only to provide access to individuals who appear to the system to be lab technicians. Setting aside whether this is an appropriate use of computer vision, let's consider this at the policy level. Would it be fair to limit access to a particular area, to a particular group of people? What if there are other functions that are critical to support the work of that part of the office, such as custodial staff? The policy enforced by this system has inadvertently then excluded those people and prevented them from doing their work. Now, that's a separate issue from whether computer vision is appropriate to use in this case, but still a very relevant one when thinking about fairness in a particular situation. And on the surface, the policy might not have intended to exclude a certain community. But what if the custodial staff in this hypothetical are more likely to be people of color? Suddenly, this policy that's being enforced by this computer vision system could have a disproportionate impact on different communities in a way that could affect their jobs. So now let's think about this on the implementation level, or how the system is working, how it was built, what are the errors? Is the system making errors that are unfairly distributed? For example, is the system less likely to recognize that someone is wearing a lab coat if that person has darker skin, long hair, religious headwear? As someone building and working on these systems, do you have a sufficiently representative test set that will let you spot whether the system is making those types of errors? Can you increase representation of training data to address some of those errors? If a CV system doesn't work as well for certain groups of people, that might lead to fairness issues as well, but ones that could at least in part be improved by fixing issues at that implementation level, fixing something at the technical level. But fixing implementation errors won't necessarily address fairness or responsibility issues that come up at the policy level or the product goal level, which is why disentangling these different lenses can help think through the different steps that might need to be taken to address potential harms of this type of technology. We need to be thinking through all of these lenses of responsibility as we're developing applications of emerging technologies like CV. I encourage you also to think about the broader context of the domains in which you're working on computer vision. Consider how the technology you're building might be oversimplifying important societal conversations or reinforcing unjust power structures. A particular architectural landmark, for instance, might be relatively easy for a CV application to recognize at a surface level, but that same architectural landmark might be at the center of an ethnic or a political conflict, and the way that you name or label that landmark might reinforce a particular historical narrative in a way that you didn't necessarily intend, or erase a group's history or identity. Take the tallest mountain in America, for example, in North America, which is in Alaska. If you were to have built a CV system before 2015 to recognize natural landmarks, this mountain might have been labeled and then subsequently recognized as Mount McKinley. But after decades of advocacy, the name of the mountain has actually in recent years been restored to one of its indigenous monikers, Denali. How will your CV applications that you're building account for changes like this? Account for the restatement of narratives that maybe didn't have the respect that they had in previous times? What does your work in CV mean for these broader political conversations, these broader conversations about identity and rights? This is, of course, just the tip of the iceberg when it comes to social and societal impacts of computer vision. There are questions of surveillance and privacy and representation and inclusion. Remember that technology is not neutral, but at every level, the product goal, the policies, even implementation choices, how much time we spend thinking through potential harms, all of these reflect our values in some way even if we don't have that intention. The resources we apply to ensuring data is collected ethically or labeled accurately or tested thoroughly, those are also critical to consider when it comes to responsible computer vision. Where are we putting our time? Where are we putting our resources? So I urge you to take a holistic approach when it comes to responsible computer vision. Don't just focus on the implementation. Don't just focus on the product goals and whether the context is appropriate. Think about all of them. Think about how they all work together and how they interact. If this field doesn't take these multidimensional and multidisciplinary issues into account early, consider the policy and the social and the potentially legal context, we'll continue to see computer vision applications deployed that have unfair and potentially harmful impact on populations that maybe we didn't foresee or maybe we didn't invest enough time early on to prevent, that violate people's expectations, making it harder for some of the potentially beneficial applications of computer vision to fulfill their potential. I really look forward to seeing what this community does and the impact you'll have on the broader field, and I thank you for having me here today.